Let's go ahead and work out this related rate problem. So for a related rate, you always want to draw a picture so that you know which formula to use to relate the two variables or three. So let's see. So car A is traveling west at 50 miles per hour. So let's suppose this is car A and it's traveling west right here. And it's traveling at a rate of 50 miles per hour. Car B is traveling north at 60 miles per hour. So let's suppose car B is here and it's traveling north, that direction. And then it's just going to keep traveling. And they're both headed for the intersection. So this is the intersection. Let's call that C. This is intersection. So now, at what rate are the cars approaching each other when A is 0.3 miles away and B is 0.4 miles away from the intersection? So we're looking for how fast is this distance changing? So let's introduce some variable. Let's call this X, that's the distance from A to the intersection, and Y represent the distance from B to the intersection, and this is Z. So we're given that the rate at which A is traveling, so that's dx dt, that's 50 miles per hour. And then the rate at which B is traveling is 60, so that's this one, dy dt, that's 60. Now, because A is approaching west and B is approaching north, their distance is getting closer to each other. So they're decreasing. So we have to put negative right here. These distances are getting smaller, so the derivatives are negative. And we're looking for what is dz dt. That's the question. So let's see, how do we set this up? So we're going to use the Pythagorean's theorem to relate these two variables. So we know that from Pythagorean's theorem, x squared plus y squared is equal to z squared. Now, let's go ahead and differentiate respect to t. So we differentiate both sides. Now this is an implicit differentiation. If you differentiate x squared, you get 2x dx dt. If you differentiate y squared, you get 2y dy dt equals derivative of z squared, that's 2z dz dt. Now because they all have 2, I can divide everything by 2. I simply get x dx dt plus y dy dt is equal to z dz dt. So I know I have this component given, I have this component given, and I'm looking for this one. This is the question mark. So these are given. Now, if you also look at the question carefully, A is 0.3 miles away and B is 4 miles away. So really this is 0.3 and Y is 0.4. And that enables you to find what Z is. So we know X, we know Y, we can find Z. Once we know Z, we can use this differential formula to figure out at what rate are they approaching the intersection. So, well, how do we do that? So going back to the Pythagorean's theorem one more time. So we know that x squared plus y squared is equal to z squared. And using this, we can find z. So I know x is 0.3 squared, y is 0.16 squared equals to z squared. And that will give us what z is. If you add them up and then you square them, you get 0.25 is equal to z squared, which means z happens to be 0.5. So that's for z. So let's substitute these into our formula. Then we have the following. So we're looking for dz dt. So we know x is 0.3. So this is 0.3. dx dt, that's negative 50, plus y, well, that's going to be 0.4, and dy dt, that's negative 60. is equal to z, which happens to be 0.5, which you just computed on the side, times dz dt. And with some manipulation, you will find what these numbers are. So you will get dz dt equals negative 30 minus 48, which would be about negative 78 miles per hour. So that's the rate of dz dt.